All right, I'm ready. So there's two very easy questions, multiple choice, to see if you guys can get them right. Very, very easy.
We're testing him.
Oh yeah, they're not just me specifically.
You in specific? I mean, you guys can help him out too.
I can phone a friend. Perfect.
You guys can do whatever you want. Yeah. You guys can even use ChatGPT if you guys want. Okay. All right. So here I have 3 box trucks, and they're completely sealed. Okay. Right? In other words, you know, they're completely sealed. Yeah. They all have an apple hanging from a string, and they're all on a level surface. The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest?
B.
B. What would you say B?
Because it's not moving, it's straight down. Right?
Yeah, exactly. You got it. Which one's accelerating forward?
A.
Why would you say A?
Because the apple's in the back, so it's like if the truck's moving forward, the apple doesn't have the same momentum to move forward. So it's moving back. Yeah, due to inertia. It gets left behind. Inertia. So the whole container is moving forward. Perfect. All right, you got it. That's the first one. So yeah. So the second one, pretty much the same. The only difference is instead of an apple with a string, it's a helium balloon. So again, the truck completely sealed, everything the same. Out of these 3, which one is at rest? See, here's the thing about helium, right? It lifts it up instead of like just holding it from the top. Yeah. So
that's why the string had to be tied to the bottom.
So B is definitely at rest.
Okay, yeah, and for the same reason as the first, because it's not moving.
Yeah.
Yeah, it's remaining vertical. Perfect. Okay, which one's accelerating forward?
See, that's where it gets weird, because with balloons, it should still stay up, right?
Sure.
I'm gonna say, but there's no air to push the balloon back.
But there is air inside.
Yeah, there's air inside.
But it's sealed from the air outside. Yeah.
Yes.
The string is attached to the truck, and the truck is moving, so the balloon's going to get moved. Right?
Yes. So I say B is also moving forward.
You say B is also moving forward?
Yes.
So, no, I'm not even talking about moving forward. I'm talking about accelerating forward.
Accelerating forward.
Yeah, which one's accelerating forward?
This is a trick question.
No, it's not a trick question.
Oh,
it's
okay,
physics.
then A.
A? Okay. A lot of people, most of the people do say A.
Oh my gosh, I knew it.
It's actually C.
I knew it was a trick. I knew it.
Well, it's not a trick, but here's the thing. The reason why it's C, I'll explain. There's 2 reasons why it's C. Mm-hmm. The first reason is helium is less dense than air. That's obvious, right? The second reason is the force. So as soon as I apply a force in this direction, the back of the truck, the wall of the back of the truck, pushes the air that's inside of the truck as well in that same direction through space. And because air is more dense than helium, the air is able to push the helium in the same direction of the applied force.
I did not know that.
So obviously helium is buoyant. So buoyancy always follows the direction of the force. Mm-hmm. So because it's less dense, it always gets pushed in the same direction as the force. So I can demonstrate that here. So this is a buoyant object, right, inside of water. Water is more dense than this ball. If I apply a force in this direction, what direction do you think the ball is going to go?
Backward.
No, forward. It goes forward with the direction of the force. See that? And that happens 100% of the time because water is more dense than air, therefore is able to push it. Water pushes air, air cannot push water.
Can I try it?
Yeah, try it.
Okay.
Yeah. That's physics, that's reality, you know? So here, I did this experiment inside of a cargo van. No, yeah, and I never thought about that either, how buoyancy, you know, it's a chain reaction of a force, literally. So here, real quick, I did this experiment in a cargo van. Here it is. I should have had this ready. Here it is. So a cargo van right here, a helium balloon and an apple. It's based on the principles of acceleration, right?
Oh.
What direction did I accelerate this cargo van? To the right or to the left?
To the right.
Exactly, because the helium balloon got pushed in that direction, showing you that the air is also being pushed in that same direction through space.
Wow.
Because that's the only way the air is able to push a helium balloon.
That's crazy.
Yeah, right? So one last question. If I have a helium balloon here on Earth and I release it, what direction does it go?
Up.
Why do you think it goes up? There's 2 reasons why it goes up.
Helium is lighter than air.
That's the first reason?
And,
what's the second reason?
Do you guys know the second reason?
Why a helium balloon rises.
Oh, aerodynamics maybe, because the shape of the balloon, maybe air pushes it up too?
No, it's actually a force. So a force, not only does it dictate the motion of the balloon, because the force is motion, but it also dictates the direction of the balloon. Because again, the direction of the force, the buoyancy always follows that direction of the force, right? So in this scenario, the truck generated the force to push the air in this direction, which then pushed the helium in the same direction. What's generating the force here on Earth to be able to push the air up, to be able to push up a helium balloon?
Winds? No.
So the air is pushing up the helium, but we know air cannot push itself. Again, in this scenario, it was the truck that pushed the air, which then pushed the helium. What's pushing up the air here on Earth, which then pushes up a helium balloon?
Temperature?
No. Again,
gravity?
Yes. It's the force of the Earth, but the force is actually a push of the Earth, not a pull. So I know we're told that we're being pulled down to the Earth by gravity. The reality is gravity is a push of the Earth. So the Earth is not pulling you down towards it, it's pushing up against you. And that same upwards push of the Earth is what's pushing up the air, which then pushes up helium balloons. So I don't know if you guys knew this, gravity as a pulling force has never been measured or detected, and that's why it's just a theory. So the pulling force of gravity is just a theory because it has never been proven. So Einstein's theory of relativity and Newton's theory of gravity, they're both basically just theories that have never been proven. So in other words, it's because it's the other way around. The force of the Earth is a push, not a pull. And buoyancy shows us that. Because the helium balloon rises because the air is being pushed up as well.
Wait, so why do we get pulled down then by gravity?
Yes, because your body has inertia. So your body resists force. So because you have mass, your body wants to remain in its position in space. So when the Earth pushing up against you, your body resists that push, and that's why you don't fly up, because your body is resisting.
Wait, so our bodies are resisting the push of the Earth?
Yes, and that's what gives us, that's inertia. Your body has inertia.
That's why we stay on the Earth?
Yes.
That's so crazy.
So when you accelerate in a car, you get pushed in the back of your seat, right? But it's not you being pushed back to your seat, it's the seat pushing up against you. That's what's happening right now. We're not being pulled down to the Earth, it's the Earth pushing up against us. So, but yeah, it is weird. You know, I don't know why. So this is the main reason why I'm doing this. You guys all believe the Earth is a ball, right? So you guys understand that on a ball, up is relative, right? So if you're standing here, up will be this way, but if you're standing down here, up will be in the opposite. In every direction away from the center will be up on a ball. If we could prove physically that gravity is a push of the Earth and not a pull, in other words, the Earth is literally moving up through space. If, again, the Earth was a ball, how can the Earth move up in every direction at the same time if it was a ball? If the Earth was moving up?
It would expand.
Yes. That means the Earth would expand. In other words, it would just explode, so it wouldn't work. So in order for people to believe in the ball Earth theory, they first have to believe in the theory of gravity being a pulling force. Because if we could prove that it's the other way around and it's a pushing force of the Earth, then the whole globe Earth concept falls apart. Because the whole globe Earth concept is built on the idea that gravity is a pull. So that's the false premise that the globe Earth starts with.
Wait, so how do we explain why the Earth is a globe if it's pushing?
But it's not a globe. So this is the #1 proof that debunks the globe Earth, actually. That the fact that gravity is a push of the Earth and not a pull. So the Earth is simply just an extended level plane that's moving up in one direction. So everybody's up is the same in reality. So if people in China, people in Australia, when you look up, everybody's looking up in the same direction. So nobody's upside down relative to each other. Everybody's right side up relative to each other. That's the reality.
So what is like?
So the Earth is a level plane, not a ball. And gravity, the force of gravity being a push is the #1 proof that shows that.
Yeah, because like if it's a ball, it's basically the Earth. It always stays like this. It just moves sideways.
You're talking about the spin of the Earth?
The spin of the Earth.
So that it only explains night and day. That has nothing to do with like an upwards push of the Earth.
Okay.
Yeah. So if we could prove that the Earth is pushing up, and the globe Earth model does actually acknowledge the upwards push of the Earth. They call it the normal force. You've heard of the normal force?
Yes.
Yes. So that's a real force of the Earth, which is buoyancy. Buoyancy is a real force, an upwards push. Gravity, on the other hand, when you release an object into freefall, there is no measurable detectable force that accelerates objects down to the Earth. You want to know why? It's because it's the Earth. When I release this object into freefall, everybody believes that the ball moves down to the Earth. But the reality is, when I release this, it's the Earth that comes up to the ball. Because everything's moving up right now. It never stops. The Earth is always moving up.
Wait, it's always moving
It's
up.
constantly moving up. And that's why we have a constant weight, and that's why there's a constant force.
But then if we're on the bottom side, or if we're on a different side of the Earth, how is it constantly?
But that's the thing. Everybody's on the same side of the Earth. Nobody's been outside of the Earth, underneath, to the side. You know, that's the globe Earth right there. That's just a concept that defies physics, in other words. So if I was to ask you guys respectfully, what's the #1 proof that makes you guys believe the Earth is a ball? Why do you guys believe the Earth is a ball?
I think for me it's because of we've seen every other planet in the system. And,
Are you saying because you were shown images?
Yeah.
Right? Anything other than that before I address that? The images, anything other than that? You have a question? Yes.
So are you basically saying like the Earth is flat?
It's not flat, it's level. It's level. So flat Earth, I know all of you have heard of flat Earth, right?
Yeah.
So flat Earth is just a topic that was brought up in the mainstream, kind of like to make fun of this whole topic. So the Earth is level. over 95% of flat earthers claim the earth is motionless. So they deny the upward push of the earth. So they're no different than like gravity. They believe in gravity too. In other words, they mock gravity, flat earthers, but the irony is that they believe in gravity as well. They just call it something else. The fact is that the earth is pushing up. And every flat earther will deny that because they've been brainwashed as well. So that's the psyop. The upward push of the earth is the reality.
Where did you learn your fact?
Reality. How buoyancy. Buoyancy, again, the ball is being pushed up right now. What's pushing up the ball? Because the ball can't push itself. The water's pushing it up, right? But what's pushing up the water? Because the water can't push it up. It's a chain reaction of the earth pushing up. So that's what it is, and that's what they did to flip it, The people believe that the force is down, but the force is up. Yeah. So the only force that exists in nature is a push. A pulling force doesn't exist in nature. Because they're claiming that an object can affect another object physically, move it without any physical interaction. So imagine this pulling this with no physical interaction. Like, doesn't make any sense. Exactly. The only way for this to push this is to physically make contact with it and push it. And this has to be moving in the same direction that this moves. That's a chain reaction. And that's what happens with buoyancy. That's the same principles.
Yeah, I get you're moving it because you're pushing it.
Yes. And then the water pushes.
Yeah.
And it's a chain reaction. That's what buoyancy is.
Okay. Because I'm just curious. Because
Yes.
I do agree with. How would you explain magnets work?
Yes, magnets. So first, you could look this up. There's a guy called Eric Lathwaite. He's back in the 70s, he did a bunch of experiments with magnets. Even he conceded nobody has a full comprehension exactly of how magnets work. But he did a lot of tests, and it basically shows that there is a magnetic field. It's like a river, put it that way. So there is some kind of flow that affects metal. So I would say that is something that's pushing metal, but it only affects metal objects. So it's still something that's pushing something else. It's still a push, in my opinion.
How do you spell his last name?
Lathwaite is Laithw.
A-I...
Yes, Eric Lathwaite. Yeah, you can look him up. He's used to do a lot of studies back in the 70s. And it's pretty eye-opening. But yeah, a lot of people do bring up the question of magnets because pulling forces, again, don't exist, but magnets do kind of give that impression, I guess, that there is some kind of pull there. But again, there is some kind of pressure difference going on there. Because when you bring a piece of metal to a magnet, you can feel the pressure increase, right? That's because there is something going on there, a physical interaction going on there. But to claim that physical interaction is happening here on Earth and affecting all matter equally, that's made up physics, in other words. That doesn't exist. So again, a pulling force of gravity doesn't exist.
What about the 9.8 meters a second?
Yes.
That's what I was trying
Yes.
to remember.
So
From Cal.
yeah. So they're measuring how long it takes for a free falling object and the Earth to meet, but they're not measuring what's going towards what. So is the object moving towards the Earth, or is the Earth moving towards the object? So they're just measuring that gap. So they're measuring a deceleration, in my opinion, of the object in free fall. So that's a deceleration rate. 9.8 meters per second is a deceleration rate. Not an acceleration. Because here's the thing, I know how easily we debunk a pulling force of gravity. So everybody's cell phone has a built-in accelerometer, and that accelerometer detects acceleration or a force, in other words. So that accelerometer enables your smartphone to be able to turn it into portrait and landscape, and it flips accordingly because that accelerometer detects the vertical force of the Earth. But that's the thing, the force is up, not down, and this is how we can prove it. If you download an accelerometer app on your phone, you're able to detect the acceleration of the phone. In other words, if it's at rest and you accelerate it in this direction or in this direction or in any direction here on Earth, it's going to detect that increase in force, right? However, if I have it at rest and I release it into free fall and people claim that it accelerates down, it should increase the acceleration, right? But guess what happens? It goes from 1G to 0G. So the phone detects a deceleration in free fall, not an acceleration. And I'm not making that up. Anybody can test this for themselves. A cell phone in free fall will not detect any acceleration whatsoever.
Wait, so shouldn't we fall slower over time instead of faster?
No, faster because the difference in speed between the free-falling object and the Earth does increase. So the longer the free-falling object has time to fall, the more it decelerates. The more it decelerates, the greater is the speed difference from the Earth and that object is going to be. So that acceleration of the object in free fall, it's only apparent because in reality it's decelerating. And that's why there's a higher impact the higher you drop something because it had more time to decelerate. So the Earth, basically, the difference in speed, it increases, in other words. So are you going to hit a car faster? Let's say you're going 100 miles an hour, right? Let's say this is a car going 100 miles an hour. And then this car is going 45 miles an hour. when this car hits this car, it's only going to hit it like at a 5 mile an hour impact, right? But if this car's completely still and this one hits it at 50 miles an hour, it's going to be a 50 mile an hour impact. So again, the more slower the object, that gets hit, the higher the impact's going to be. So, does that make sense?
Yeah.
Yeah. So the higher you drop something, the higher it's gonna, and more time it's gonna have to decelerate, and that's why there's gonna be a higher impact of the Earth.
Oh shoot.
Yeah. Trust me, they just flip the script.
It feels so off. It feels like the opposite of what we learned.
Exactly. Because it is. It literally is. They literally turned the world upside down for us. Literally.
When did you learn about this?
10 years ago.
10 years ago?
Yeah. So
How old are
I'm
you?
34. So I found this out when I was 24. I'm sure you guys are probably younger than that.
Yeah.
So believe it or not, if you guys take this on board, you guys will be way ahead of me. Because again, I came across this when I was 24 in 2016. And literally there was not really a lot of information out. All the information that you see nowadays is all just bullshit information. Again, all these motionless flat earthers are flooding the internet. Because that's the controlled opposition. That's how they're controlling this narrative. So it's like Democrats versus Republicans. It's like, it doesn't matter who wins, right?
They're arguing about the wrong thing.
Exactly. So motionless flat earthers and globe earthers are arguing about what gravity is when gravity doesn't even exist. When gravity is just the push of the Earth. But then you're having these fucking 2-hour-long debates about what gravity is when they're both believing objects accelerate down, which is fucking ridiculous. But again, both flat earthers and globe earthers run from people like me. They literally run away. Literally. They don't want to have the conversation on, especially on camera. They don't want to have it because they're gonna made look like fools, in other words. So everybody's running away from this fact that the Earth is pushing up. That's the number one fact that debunks the globe Earth and the motionless flat Earth. So yeah, any other questions before you guys go?
No, I'm gonna do more research.
No, yeah, definitely. So here's my channel. Let me give you guys my channel, and you guys can check it out. And I'm telling you, this is easily the number one censored topic right now, like by far, more than any other subject that I've ever came across. This is the most censored. We have one more. And yeah, I implore you guys to check it out. And again, if you guys are open-minded, this will be right up your alley. You know what I'm saying? So let me ask you guys this before you go. Is there a possibility that we have been lied to about the nature of the Earth? Or are you guys 100% convinced that it is a ball in outer space?
Well, I mean, to be fair, no theory is really 100% proven.
Exactly.
Science is always changing.
Exactly.
So it's not
only take you so far.
Exactly.
Yeah.
Do you accept scientific facts or objective truths, which are the opposite of theories? Yeah, I would say that the Earth being level is a scientific fact. So it's not a theory. The globe Earth is a theory. So I would say those are the two differences. And again, it's all about, you looking into it and understanding it for yourself.
What do you mean by level?
Level means horizontal perpendicular to the vertical. So no deviation in
like the magnetic poles kind of?
Well, yeah. Well, you know what a plumb line is? It's true vertical, right? Mm-hmm. True vertical. So level will be perpendicular to the vertical, which will be 90 degrees from the vertical. So a straight line perpendicular to the vertical. So here's another thing about reality. All plumb lines here in reality are considered parallel to each other. So all vertical lines, regardless of distance, are parallel. On a globe Earth, all plumb lines should converge to a center. So you couldn't have plumb lines be parallel on a globe, but in reality they are. So all engineers that build bridges, 100-mile long bridges, railroads, all that, they don't take account of Earth's curvature, and they assume that all plumb lines are parallel to each other, which will only work from a level Earth, not a globe. So a globe Earth, if you look, all plumb lines converge to a center.
And what's a plumb line?
A plumb line is a vertical line. It's basically the force of the Earth.
Also, a bunch of plumb lines converging to a center.
Yes, that's what a globe. Because if you hold a plumb line, for example, if you have a ball, what did I do with the ball? If you have a ball, for example, your plumb line here, reference up, your plumb line is up, in other words. So their plumb line will be this way, but if you're standing here, your plumb line will be this way.
Yeah.
So those two plumb lines are will converge at 90 degrees. But in reality, all plumb lines are parallel, meaning they're all facing the same direction. That's reality.
So kind of like how kind of like the ball, how these are like the north and south poles. The plumb lines kind of converging on them, right?
The plumb lines converge to the center of the Earth.
The center?
Yes, because all plumb lines point to the center.
Oh, okay.
Yeah, on a ball.
Oh, that's new.
But in reality, all plumb lines are just perpendicular to the level, like this.
So the Earth is kind of like, so the Earth is more like a few pieces.
Well, the Earth is just an extended plane, a horizontal plane.
Horizontal extended.
Yeah, level is horizontal. Horizontal is just another word for level as well.
Level.
Yeah.
So it's more like It's more like a wrapping around the circle than a circle, right?
Well, it's not even a circle, I would say. I would say the Earth, the surface of it is just a horizontal surface. What does it look like underneath and outside? I have no clue. All I know is that life can only exist on the surface, which is horizontal.
But we do know, we have seen images of the Earth.
Yeah, so images. I know you guys brought them up. Let me just show you guys these real quick. So these are official images of the Earth from outer space from NASA, 2002 and 2012. They admit that they don't have real photographs of the Earth from outer space. So these are all CGI, admittedly so. So they say that they can't go high enough, even though they suppose they went to the moon in 1972.
That's confusing.
Yeah, I know, it is. So they have a lot of bullshit explanations about a lot of stuff that doesn't make sense. So yeah, they admit that these are all Photoshop and they're all made in the computer, and the excuse is they can't go high enough.
There's no way.
Yeah. So, and the reality is that these images defy physics at the end of the day. They don't exist. Not only do these images, again, show water bending, which is physically impossible, but again, an upwards push of the Earth from a globalist perspective just wouldn't work, you know. But again, they admit it's not even up for debate. So here's the thing: if I showed you an image of me flying, would that be evidence that I can fly? No, right?
You could just freeze the image.
Exactly. An image or a video can easily be manipulated. Would you agree? Especially with CGI and AI nowadays.
Oh, yeah.
So an image or a video of something to be considered true is not good enough for me. So if something is true, it has to be measurable, testable, and repeatable, which is a scientific method.
So only really astronauts actually know.
Well, I would say only really astronauts are the ones that have to be lying, you know, in my opinion. But yeah, they for sure have to know it.
But why would they lie about it?
Well, first of all, it's they get paid a lot of money, first of all.
Yeah.
I don't know if you knew anybody that works for NASA, or even if you have a government contract with NASA, you don't even have to work for them.
But
you sign NDAs.
But even if they send the NDAs, what would the governments even benefit from lying about this?
Okay, so why would they lie about this?
Yeah.
So it's very simple. So in my opinion, they lied to us to try to control us. So here's the thing: to physically control humans, it's way harder than to physically control animals, right? Because animals, you can just physically put them in a pen, put a fence, and they can't leave anymore. With human beings, it'll be much harder to do that, right? So you got to control human beings psychologically. So what do? You lie to them about the nature of their existence, you lie to them about the nature of the Earth, and you lie to them about how we should be living. So the lie about the shape of the Earth is just to gain our trust and to basically make us just believe authority over our own common sense. So it's a cheap shot on our common sense so that we're more easily controlled. So that's why they lie to us about your space, is to control us. So we live in tax farms, that's what it is. And we're basically being psychologically controlled. So we don't leave the tax farms like animals would. I don't know if you knew, actually, with animals, when they have a fence, for example, and it's like an electric fence, and once they get electrocuted so many times and you remove the fence, the animals don't leave. You know, they're kind of like mentally stuck there.
I've heard about stuff like this.
I feel like yes.
The flea in the bottle, or like the elephant with like the hook on the ground.
Yes, the flea in the bottle one's a good one too. So they don't jump higher than the bottle.
They don't jump higher than the bottle because they don't think they can.
Yes, and even after they remove it. Yeah, so human beings, I believe, is the exact same thing and that's why they lie to it, because it's a psychological attack. That's what it is. That's what they lie to us. So yeah. So what do you guys think? You think this is something important to look into?
For sure, yeah.
Yeah, definitely, right?
I'll definitely look at the brochure.
No, yeah, definitely. So, yeah, man, I appreciate the chat, and yeah, I'll be here. My name's William.
William.
It's on the flyer. Yeah, you guys take care, man. Appreciate the chat.
Nice to meet you.
All right, take care.
Have a good day.
All right, man, you too. So, yeah, 2 very easy questions, multiple choice. Again. So, here, I have... Okay, they want to do it? Yeah, you guys can do it together, all together. I'm barely gonna start. All right, so I have 2 multiple choice questions. This is the first one. So I have 3 box trucks here, and they're completely sealed. They're all on a level surface, and they all have an apple hanging from a string. The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest?
This one.
Okay, you guys all agree? B, yeah? Why do you guys say B?
Because it's not moving.
Yeah, pretty easy, right? Pretty obvious. Which one's accelerating forward?
A.
Yes, how do you guys know?
On the apple's moving backwards.
Yeah, it's due to inertia, obviously. So the whole container is moving forward and the apple's being left behind. So yeah, it's due to inertia. You guys got it, yeah. So the second one, pretty similar, but instead of an apple, it's a helium balloon. So out of these 3, which one is at rest?
B.
Yes, it's for the exact same reason as the first. There's no movement from the vertical. So which one's accelerating forward?
A, right?
C.
C.
C? Okay, it is C. Why do you say C though?
Because it's moving backwards, but the balloon is moving forwards.
But why does it move forward? No, this one is accelerating forward. This one is accelerating forward.
The truck is
This one's accelerating forward, and the balloon goes forward. But do you know why the balloon goes forward, though? That's the question.
It's gonna be something with helium on the it being lighter than air.
Yeah, there's two reasons, and that's the first reason. Yeah, so there is two reasons why this one is, the first reason is helium is less dense than air, and the second reason is a force, because you require a force for motion, right?
Yeah.
So when I apply a force in this direction, for example, the truck pushing the air in this direction also pushes the helium because air is more dense than helium. So when the air is moving in this direction through space, it's able to push the helium in that same direction because air is more dense. So that will be a buoyant effect. Yeah, buoyancy is a chain reaction of a force, and buoyancy always follows the direction of the force. So for example, here's a buoyant object, right? This ball is less dense than the water that surrounds it, right? If I apply a force in this direction, what direction will the ball go?
The same direction.
Same direction as the force, yes, because it's buoyant. See, it goes forward because buoyancy always follows the direction of the force. Yeah, so that's reality, right? So here, I recreated this experiment in a cargo van, and based on these principles, what direction would you guys say I accelerated this cargo van? To the right or to the left?
To the right.
Yes, exactly. Because not only does the helium balloon get pushed forward, but the air also has to be moving in that same direction to be able to push the helium. So yeah, I accelerated in this direction, and the apple got left behind. You know. So here, one last question. If I have a helium balloon here on Earth, because helium is buoyant here on Earth, right? If I release it, what direction does it go?
Up.
Yes. There's two reasons why a helium balloon rises again. Why do you guys think it rises?
It's lighter than air.
That's the first reason. What's the second reason?
It's more concentrated in the helium balloon?
No, well that's the densities. Oh, yeah. That's the density difference. But what's the second reason? What creates motion?
Gravity.
Force. Yes. So we need a force as well. So in this scenario, the truck generated the force to be able to push the air in this direction, which then pushed the helium in the same direction as the force. What's generating the force here on Earth to be able to push up the air to be able to push up the helium?
So gravity, right?
Gravity. So the force of the Earth, but here's the thing, the force of the Earth is actually a push, not a pull. So I know we've been told that when you release an object into free fall, that gravity pulls everything down. So we're being pulled down to the Earth, right? The reality is, it's the Earth pushing up instead. So that's where they did the flip. So gravity is a push of the Earth, not a pull, and buoyancy shows us that. So that upwards push of the Earth is what's pushing up the air, which is able to push up helium balloons. So I don't know if you guys heard of the normal force. So that's the globe Earth acknowledges the normal force. It's the opposite to the pulling force of gravity, but the normal force is the only force that actually exists. So I don't know if you guys knew, the pulling force of gravity is actually just the theory. So Einstein's theory of relativity is just a theory to explain why objects appear to go down, because there is no measurable force down. The force is up. So the fact is, this doesn't move down to the Earth. It's the Earth that moves up to the object when you release it, because everything's constantly moving up right now. We're all being pushed up right now through space. So here's the real reason why I'm doing this. You guys all believe the Earth is a ball, right?
Yeah.
So you guys understand that on a ball, up is relative, right? So if you're standing here, up is this way, but if you're standing down here, up is in the opposite direction from this person. In every direction away from the center will be up on a ball, right? If we could prove physically that the Earth is literally pushing up and not pulling down, and buoyancy shows us that, how can the Earth move up in every direction at the same time if it was a ball? Right?
Yeah.
So the fact is, it wouldn't work. That would mean the Earth will have to be expanding to be able to push up in every direction away from the center. So that would mean the Earth would just explode, which wouldn't work. So in order for people to believe in the ball Earth theory, they first have to believe in the theory of gravity being a pulling force. Because if we could prove that it's the pushing force of the Earth that we experience here, then that would debunk the entire whole globe Earth model. So that would be the number one proof to debunk the globe Earth, is the fact that gravity is a push of the Earth, not a pull. So the Earth, in reality, is just an extended level plane that's pushing up in one direction. So everybody's up is the same. Up is not relative.
Wait, so you think the Earth is flat?
It's not flat, it's level. So the difference between flat and level is that level requires a force, because level is an orientation, which requires the vertical force of the Earth. But that force is up, not down. Flat Earth, on the other hand, over 95% of flat earthers claim the Earth is motionless. So they deny the upwards push of the Earth. That's the controlled opposition. That's the PSYOP.
So what shape do you think
the Earth is a level extended plane. What it looks like as a whole from the outside, I have no clue. Nobody's been outside of the Earth to be able to see it from a God's point of view, pretty much. So the Earth is a contained system. So we have air pressure here on Earth, 14.7 psi. In order to maintain air pressure, you require solid containment. Otherwise, the air pressure would just rush into a negative pressure.
Yeah, but
without.
here's the thing, though.
Yes.
So if you're saying that gravity's not
A pull.
do you believe in gravity?
Yes, it's a push of the Earth,
Okay.
not a
So
pull.
thank you.
Yeah, no worries. You guys take care.
Acceleration due to gravity would be
Acceleration in free fall you're talking about?
yes.
Yes, I would say that's deceleration. It's not acceleration.
Deceleration and acceleration are the same.
You can say that, but when I release this object, you believe that this object physically moved down through space.
But here's the
The
thing.
reality is the ground moved up to the object.
Sure, but
Yeah.
every object does have a gravitational pull. The issue is
It
it's
doesn't.
based off yes, it does. So
Well, a downward physical force has never been measured or detected. That's why Einstein's theory of relativity is just a theory.
a theory, a scientific theory, is something that is. We say it's a theory because it can always be proven, right? That's what a theory is. It can always be proven. That being said, it has been gravitational waves have been measured. I don't know if you know about LIGO, but gravitational waves have.
I've heard of them. Here, you guys can check out my channel. Yeah.
You're posting this?
Yeah,
Everything-
yeah,
So you know the laws of Newton's laws, right?
yeah.
Everything has an equal opposite reaction.
Yeah, so the laws of...
So when
yeah.
I
You guys should take that with you.
Oh,
Yeah.
you're live right now?
Yeah.
right?
Yeah.
I have a gravitational pull.
Well, I would...
It's so minute that it really doesn't matter. So I'm not pulling the Earth to me.
No,
I
you're
am
not. You're not.
Technically I am, but it's such a small force that it doesn't change anything about me,
Right.
right?
Did you know that Einstein's general theory of relativity claims that there is no force in free fall?
What do you mean?
So Einstein's theory of relativity basically claims that it's the bending and warping of space-time that moves objects down, not accelerate them down. So he acknowledges that there is no physical downwards acceleration of matter. And that's why he came up with his theory of the bending and warping of space-time.
Anything moving, right? Like if it's changing direction, that's an acceleration.
Sure, yeah, changing direction is
So
also...
force causes acceleration.
Yeah, in order to have acceleration, you require a force.
Yes.
Right. So when you release an object into free fall, people claim that this accelerates down toward the Earth. However,
Acceleration due to gravity, which can be measured.
No. So
9.8 meters per second
So
squared. Can
you have a
be
smartphone,
measured.
obviously, right?
Yes.
Your smartphone, everyone's smartphone, has a built-in accelerometer inside of our smartphone. So when you have it in landscape and portrait, yeah, take care, man. So when you have it in landscape and portrait, it changes because it detects the vertical force of the Earth, right? You believe that that force is down, but I'm telling you it's up, and I'm going to show you how we know that. So if you download an accelerometer app on your phone, you're able to detect the acceleration of the phone. So if you have the phone at rest and you accelerate in any direction, up, down, left, right, that accelerometer will detect an increase in 1G because you're accelerating it, right?
Yeah.
When I have it here at rest and I release it into free fall and people would claim it accelerates down towards the Earth, guess what happens? It measures a deceleration. It goes from 1G to 0G when it should be...
Acceleration is still
We should be, but when I physically accelerate down, it goes from 1G to 2, 3, 4, depending on how.
Yeah, have you ever done projectile motion? Do you know kinematic equations?
Sure, I don't know the kinematic equations, but what are you trying to get to?
Okay, so I just finished my physics
Sure,
class recently.
sure.
We were doing the lab. Part of the lab we've done last week
Yeah.
was we were measuring the acceleration due to gravity.
Okay.
So you throw
How did you?
something up,
Yeah.
or you drop something. We'll say dropping something because that's a one-dimensional. You don't have to worry about
Sure.
the x or y dimension, right? Y or x dimension.
Sure.
If you drop something based off the distance and the time it takes for it to start here and land there, using kinematic equations, no matter how far up you drop, with negligible air resistance, right? The second you go higher up, then air resistance becomes something you have to consider.
Yeah.
You will get roughly the same. Yeah, it's like
So this is the guy
gravity's
that
not
says
real.
velocity isn't real.
What do you mean? Acceleration is real. In free fall, there's no acceleration though. Yeah, acceleration in free fall is not real.
He's saying
It's
that
decelerating.
gravity
Okay,
is-
so what you're measuring, distance over time. You're measuring when you drop an object, how long it takes.
acceleration due
Okay,
to gravity, yeah.
if I drop this object, right, and
Yes.
we can measure how long it took for the object and the Earth to meet, how do we know that it was the object that met the Earth and not the Earth that met the object?
So, here's the thing. The Earth does move a very, 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 so small that honestly it's not something you can do.
Okay.
The Earth does move because everyone that has a mass, anything that has a mass does have a force due
But-
to gravity.
But you believe it moves in
As
4
it-
different directions at the same time. Because you guys believe that the Earth is spinning, right? That's one motion.
Exactly.
You guys believe that it's revolving around the sun.
Also has to move to the Earth.
That's the second motion. Then the whole solar system is rotating around the Milky Way. That's the third motion. And then
The reference frame is the ball.
It's all just
Yes.
Then the ball is
relationship between
If it's a system, you're measuring the system. You're dropping the ball from Freefall, right?
different
course.
And the ball gets to the Earth.
Yeah.
it's attraction. It's like if something is like attached to me.
That's
yeah,
the ball
but
moving.
that's built on the premise that you believe that when I release this, that there's a pulling force of gravity. If we could debunk that, just hypothetically, if we could debunk that objects don't accelerate down towards the Earth and it's the Earth that moves up to the object, how can the globe Earth exist after that? Or would you admit that it wouldn't work?
Just like you have a gravitational force, I got a gravitational force. It's just
Yes.
so small and minuscule.
Well,
that-
physics shows that. Because yes, it shows that because
Stabilize
yes.
it on the ball.
Everything
You would see everything else move
stationary.
That's what it appears. That's what it appears like because everything's moving up together. It appears to us that everything else is stationary relative to us because we're also moving. But when something's not connected to the Earth, like this in freefall, we cannot see a motion. People think that this moves down, but it's everything else that's just moving up, and this falls.
To say it like something you're attached to it.
Yes.
The whole thing is moving.
So technically, you're moving with it because you're attached to it. Exactly.
So how would you explain satellites and orbital motion?
So orbits again, they rely on the idea that there is a gravitational pull of the Earth, and and they're being orbited around the Earth. So again, all of those are based on assumptions. So what they're showing us
So
from,
Starlink for stars.
I would say whatever they're showing. I'm sorry.
am?
Oh well, then that's good for you.
So is there like a test or?
Yeah, it's just
So,
a
like,
test. Yeah.
Starlink, you know,
Here,
the
you guys can-
satellites you can observe in the sky.
Yeah.
How do you think those work?
So I would say if we could see lights in the sky moving, apparent motion of something moving in the sky, I would say that they're most likely like some kind of high altitude drone plane that an app, that an app can follow. So when you're thinking looking at the ISS or anything above, and it shows you on a map on an app, and you see it move above your head, I would say that that's just a high altitude drone that's been programmed into the app.
Yes, but Starlink has to orbit the
It's
Earth.
not in outer space, in my opinion. It's in literally it's just above the Earth, circling. It's not going around a sphere. It's just going around a level surface, like this. If anything that's above the Earth is just going over a level surface.
Okay, so you think it's just a plane, right?
Yeah,
Fine.
nobody's been to outer space.
If you
In
were
other
in
words,
an airplane, right?
Yes.
So you don't believe in the sphere. of
No,
Earth,
the
right?
globe Earth
Okay.
sphere. No.
If I'm in an airplane and I start at one point, how would I get that from that
Here,
one
guys can
point
take this. Sorry.
around the Earth to the other point?
So okay, here I'll show you. So here.
Yes, I would.
Right? Who wouldn't? Oh, here. Let me show you real quick. Talking about circumnavigation, right?
Yes.
Yes. Yeah. I have it right here.
Are you a 5th grader personally?
No.
Oh. So can I be smarter than you or like?
We're all the same equal. If you are honest with yourself, we're all equally smart at the end of the
True
day.
as fuck, bro. That's some facts.
Oh my god, where is it? Son of a gun. Oh my god, it's probably... Okay, I'm gonna have to take all this out. Because I usually don't like to show any maps, but circumnavigation is a good way to show this. Oh my god.
Why wouldn't you like to show that?
Because nobody knows the true layout of the Earth. Everything that we've been shown, I don't know if you knew, a 100% accurate map of the Earth doesn't exist. So the
Yes,
Mercator
that's
map,
because
all the maps don't work.
Because if the Earth is a globe, which most science proves that it is a globe, you cannot accurately depict a three-dimensional thing in a two-dimensional thing.
Okay, so here's my bad. I had it all the way in the bottom. So here, so if we had a globe, yeah, no worries, take care. So if we had a globe, again, I don't say that this is accurate because I don't believe in this map. But if we just flattened out a globe, you know, if we had the north,
can't accurately do.
sure, yeah, sure.
In
But
a
if
two-dimensional,
sure,
yeah.
but if we were to flatten out a globe, this is what it would look like. The south would just be a ring
Sure, yeah.
around the holding the water in. So circumnavigation, so the north will be the center point, right? If we go east and west, using the North Pole as a reference, we'll literally just make circles around the level surface. East and west will just be circles around the center point. So that will be circumnavigation. So if you head east this way, you keep going east, you just come back to the same location, or west. And if you go east, you just come back to the same location again. What nobody has ever done is south to north navigation. So nobody's gone to the South Pole, come back around up to the North Pole, because in reality, guess what happens if you go south? You're not going to come back to the same spot because it's not bending down.
No, the issue is that flying over airspaces like this are incredibly dangerous.
Yeah, they're restricted, sure.
Yeah, and restricted.
Sure.
So there's a reason you can't, is because they're incredibly dangerous. Also, this is a lot further without getting somewhere where you can be. So it's honestly probably not the best idea.
Mm-hmm.
But going, do you have your sphere?
Yes.
Going from east to west, right? If I'm here, I can go all the way around.
And come back.
To the same point.
Yes, that can be done from a level 2. Again, if you're here and you head west this way, this line, we'll say this line's west, you come back around the same way.
Sure, okay, now pretend that we don't have this ice, right?
Sure.
We don't have these dangerous airspaces or airspaces we can't go through.
Sure.
If we're able to do this around in a circle, that's basically the same as doing this.
Technically, yes.
Yes.
But nobody's ever done that.
Yes, for reasons I've already mentioned.
So you just have to assume that those reasons are true, and you have to assume that.
I'm saying that in the grand scheme of things, the idea of gravity, I mean, we don't have a perfect idea of gravity. It's one of the harder forces to, like, scientifically explain. But without this idea or concept of gravity, right?
Sure.
And the idea that the Earth is round, then our other observations, like the moon or nebulas or anything off into the further reaches of space, breaks down. You can't.
Sure. I would say that all of those observations, again, you made a point there, all of those observations are just that, observations. And I would say that those observations are basically built off a false premise that the Earth is a globe, which is built off a false premise that the force of the Earth is a pull.
So what's your opinion on other planets then?
So here, I'll show you. So I don't know what the lights in the sky are exactly.
The stars?
The stars, yeah. I just call them lights. We call them stars, obviously. But I don't know what they are. But here I have images that anyone can take if you have a powerful zoom camera. Here we go. So this is what the stars look like when you actually zoom into them. So, and it looks like they're just light that's changing colors, and it looks like they're rippling in water, literally. So in my opinion, outer space, it's probably water. I'm not saying that for sure. I can't prove that, but
no, because what this really is, the reasons like stars twinkle is because of space. I guess space dust is the best way to explain it, because of the distance.
Sure.
We can measure how far away other solar systems and other planets are because of red light shift.
Okay, sure.
So you're able to tell how far away something is based off
light.
Yes, which is something we can also measure here in Earth as a whole. We can measure that in the Earth using
spectrometers.
Spectrometers.
Okay,
yes.
so these are the planets, which again, using the exact same zoom camera, 82 times zoom, optical zoom, you're able to bring them into focus just like the stars. But here's the thing, they say that the stars are way further away than the planets. But how is it that we were able to bring them both into focus? That shows me that they're both, the lights that we see, the stars and the planets, they're literally just lights that are, in my opinion, within the Earth's atmosphere. They're reflecting off of, I don't know, maybe the ceiling that we have here, I don't know. But point being, I don't know what they are, but the most important thing is that looking at the stars and the sun and the moon to prove the geometry of the Earth is a red herring. It's a false argument because, again, looking at the sky tells us nothing about the geometry of the Earth physically.
Yeah. Sure, but there's a lot of, on your part, there's a lot of, I don't know, assumptions as well.
Well, here's not an assumption. So do you know the radius of the Earth?
Not memorized, but
okay, so the radius of the Earth that they tell us is 3,959 miles, and you can double check this. And based on the radius of the Earth, you can calculate for the circumference, which is the distance around the Earth, which is 24,901 miles, allegedly, based on the numbers they're giving us.
Yeah.
Using a simple calculation like the Pythagorean theorem, a squared plus b squared equals c squared, we can calculate for how much curvature there should be every mile using this formula. So you can use this formula, put in the numbers that they gave us, and we'll get how much curvature there should be. So there should be 8 inches per mile squared. That means in the first mile there should be 8 inches of curve, second mile 32 inches, and by the third mile there should be 6 feet of measurable curvature. So how do we measure for that curve, right? There's a very easy way to do it. So if we went out to a giant lake that was miles across, for example, we'll say 3 miles, and the water was fully contained and at rest, if we build a level structure over that body of water, in other words, a perfectly horizontal structure over the body of water, the water is going to level out parallel to anything horizontal above it, because the physics of water, when contained and at rest, shows that the surface always equalizes. It forms an equal surface, which is level, which is horizontal. Again, you can observe that at any scale, any pool. The surface always equalizes, right? They're trying to tell us that the surface of every lake is bending 8 inches per mile squared, which would mean there'd be a 6-foot deviation from the starting point to the end point.
So people have also disproven
So
this whole state, not this one, the other one. I don't know if you've ever watched some of the flat Earth experiments.
Yes, those are faulty experiments, like the laser experiments, for example.
Yes.
Yeah, so laser experiments wouldn't work because what happens when you shine a laser through water? Does it go straight?
No, it bends.
Why does it bend?
Because,
Refraction.
yes.
You know the air has moisture in it, right?
Yeah.
So what happens when you shine a laser through it? You think the laser's gonna go
So
straight?
I guess my thing is, there's some science I do believe in, but then there's other science you
Well,
don't
I would
believe in.
say
So it's more like picking and choosing, I guess, which...
Nope.
you
Because
believe
the
to
laser
prove the point.
experiment, I'm calling it out as a faulty experiment due to refraction, which anyone will agree that there's going to be refraction, especially the further distance you measure the laser, the more refraction there's going to be and the less power the laser is going to have too. So a better measurement will be this, a physical structure that we can literally build level, and then we can measure the surface of water to see if it actually bends or not. Because
So do you
this would
know
be
how much a laser refracts in air? Do you know how much?
I don't know the
refraction is?
exact rate.
So
it depends on the how much density
Yes,
there is
so
too, and the moisture.
using a laser, right?
Sure.
Based off refraction, which I'm pretty sure in air is very, very slim, nothing near compared to refraction in this.
I mean, I think the further distance you measure, the more there's going to be, the more you have to account. So if we're measuring 3 miles,
but
there's going to be
if you're
something.
using a really strong laser, then it shouldn't matter all that much.
That's
It would
the
be
thing.
an almost near negligible number.
I would say it would be very negligible. Like it will be very noticeable. Like it wouldn't be a concrete, definitive answer, in my opinion. Like people would just say, "Oh, it's."
So what would someone have to do to prove to you that
a physical measurement that we built 100% level, and then we can measure to see if the surface of water bends relative to it. Because again, the oceans are supposedly bending around a ball, so every lake on Earth should be displaying this curvature as well, because lakes have to be bending around a ball as well. Would you
I would
agree?
have to double check your math on this, but
Yes,
I'm almost
please.
positive that this has been the idea that there's no curvature when you're looking at water, you're looking at a distance, has been disproven.
It hasn't. I've been in this subject for over 10 years, and I'm telling you, this in specific, not only that, the upwards push of the Earth are the two main things that are being avoided, not only by globe earthers, but by motionless flat earthers as well.
So
motionless,
why would the Earth go up though?
because
why?
otherwise we wouldn't walk. We need a force to keep us on the ground.
Yes,
A
gravity.
pulling force of gravity is it's cartoon physics. That kind of force doesn't exist in nature. The only force that exists in nature is push. It's pressure variant. So everything that has motion requires pressure. There's no such thing as pull with no pressure.
So there's equal and opposite forces,
Yes,
right?
yes.
So a pull has to have a push.
No. A
That's
push
equal and
a push
opposite.
has resistance due to inertia. So your weight is the cause of the upwards push of the Earth and your inertia resisting it. That's the equal and opposite. It's your inertia resisting the upwards
So you're
push.
talking about the normal force.
Yeah, the normal force of the Earth is
Yes.
the only real force that exists.
Normal force exists in comparison with the force due to gravity.
So
the reason this doesn't go straight through the table is the normal force of the table pushing up on the water.
But in order for the table to be able to push up, the table has to be moving out through space. It's like saying, in order for me to push this, I have to literally be moving my hand in this direction to be able to
that
push
would
on
mean
it.
everything is constantly accelerating
Yes.
upwards.
Yes. That's what's happening. That's reality. That's what physics shows.
Why would that be?
Because that's what buoyancy. So a buoyant object will always get pushed in the same direction as the applied force. So this is a buoyant object, right? If I apply a force in this direction, the motion of the water, because the water is more dense, is able to push the buoyant object in the same direction as the force, right? Because that's how it works. The more dense pushes on the less dense, right?
Okay, yeah.
So right now the ball is being pushed up right now. The less dense is being pushed up. But we know water can't create pressure on itself. So what's creating the pressure of the water pushing up right now?
What's keeping the water contained in?
Well, this
Gravity.
container. Well, inertia, the reason why the water has weight, in other words, is because water has inertia. Inertia is
So
resistance to
in order
motion.
for anything to be at net zero, force net zero,
Sure.
right? Equilibrium.
That doesn't exist.
The force in normal has to equal the force due to gravity. That's the only way something can be in an equilibrium on Earth's system.
Sure, equilibrium as
Because
in...
the second you say that the force normal, right, and the force of gravity doesn't exist, then everything's constantly accelerating upwards. What's stopping some things from accelerating upwards faster than others?
Well, because we rely on the upwards push of the Earth to keep
Well,
us
are
on
you
Earth.
aware that I'm currently exerting a force downwards
Yes,
on the Earth?
that you know why that force, that it's a fictitious force, the force that you're exerting down, it's due to inertia. So it's a resistance, it's not a force. So the force that you're applying down is inertia, but it's a resistance. You're not moving down towards the Earth. You're
I'm just
resisting.
saying, if
You're just
you're going to say, like, use things like inertia and things like that,
Yeah.
right?
Yeah.
Which are all physics concepts
Sure.
based around this principle of gravity. A lot
Yes.
of science, right,
Mhm.
is kind of based around this idea of gravity, is how we figured
Yes.
out how to get satellites up in the air. It's how we're able to figure out projectile motion, and how if I launch something at a certain angle, I can tell how far it's going to land based off the mass and things like that, right?
But that's because we're measuring the distance of how long it takes for the Earth and the object to meet as well. We're calculating for that. But you're thinking that it's being pulled down, but I'm telling you it's just the Earth coming up.
I'm saying that, yes, we do pull the Earth up. If I were to jump, yes, the Earth moves very, 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 very minusculely to come and meet me, because I have a gravitational pull, you have a gravitational pull, he's got a gravitational pull, this table has a gravitational pull. We have such a small gravitational pull in comparison to the Earth that any movement I make towards this Earth is incredibly, incredibly minuscule.
So so what you're saying is you're basing this on the concept that mass attracts mass, and because you have mass, when you jump, you affect the Earth.
Yes.
Okay, so that idea of mass attracting mass, that's just a concept that's based off of nothing physical. So it's just an idea that's based off of nothing physical, nothing practical. You
The
cannot.
second you start saying things like that, then any other argument you've currently made breaks down. Like,
No. Well, here's the thing. You're
the
claiming.
stars where you don't know what these stars are.
Well, the stars prove nothing about the geometry of the Earth. That's the thing. So I know nothing about the sky. I admit that. But that doesn't mean the Earth is a globe. Does that make sense? Because again, looking at the
Except
stars,
for the fact that we have
you can make predictions.
people who've gone to the moon.
Well, I
And
would
we
say.
have orbital motion around the Earth.
Well, I would say the people that you believe went to the moon is just that. You just believe that. Have you actually seen the footage from the moon landing?
Yes.
You have seen it?
Yeah.
You think they actually went to the moon?
Yes.
Yeah, really?
Yes.
Wow. Okay. Well, I've seen the footage, and it's pretty laughable. Like, like that was their attempt of trying to make it look futuristic back in the 70s. It's just a joke.
So you don't believe in the moon?
No, 100% no. So yeah. So if you believe in that story, I guess that's what kind of fuels your whole belief in the globe Earth as well, right? Can we
Then
say that?
what fuels your belief? What made you decide, yeah, no, the math that has been proven over and over and
So
over
it started with this. This is the number 2 proof, the physics of water.
Okay,
so
so that's where a lot of flat earthers stop.
Yes, yes. So the physics of water, again, you cannot show me a large body of water contained that's bending and maintaining that bend.
The ocean?
That's the thing. Have you heard of the term sea level?
Yeah.
Do you know what level means? You can look up the definition for level right now. It's horizontal.
So that's
So the oceans are horizontal.
not exactly what they mean when they say level.
Yeah.
Right?
So again, that still defies the physics of water when contained in at rest. That would mean, again, that you have to believe that the oceans are being bent around the ball and stuck.
So if the Earth were flat, or a
Level.
plane, or level as you
Level.
say, right? Then I should be able to get rid of everything here, right? Everything's flat, right?
Yes.
I should be able to pretend there's no trees or whatever in my way. I should be able to see my apartment multiple miles that way.
There's 2 reasons why you won't be able to see it,
Why?
even if you remove everything. So
Why?
2 reasons. So one reason is perspective. So we do have a limit to how far we can see. So we don't have Superman eyes. So there's a reason why when something is in front of you and it moves away from you, does it shrink or does it not? Does it appear to shrink? Like if I have something in front of you, but then I start moving away, does it appear to shrink in your
Yeah,
field of
it's
view?
based off perspective, yes.
Exactly. So everything converges to a point because we do have a limit to how far we can see. So that point of convergence is our limit of perspective, which is the horizon. So the horizon is apparent, not physical. So everyone has their own horizons based on their altitude because again, the horizon is only an apparent thing that happens because of our eyesight. It's not a physical curve of the Earth. So that's the first thing. We do have a
Well,
limit.
it'd also be based off how tall and
Yes,
height.
yes, and how high you are. Yes, so it's all due to
So
perspective.
if there was something really, 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 really tall off in that direction, I should be able to see it.
Maybe just the top of it, and if you go further and further and further, eventually you won't. That's why you're able to see mountains, but not the full mountain. You only see the top of it because the bottom's being blocked by perspective. You're not by the curve of the Earth.
And also
So the second reason why you won't be able to see forever is atmospheric
So okay, we're gonna pretend
conditions, atmospheric
that
conditions.
the Earth is a very flat plane, right?
Yes,
That just
level.
stretches on a level plane.
Yeah.
What is your how would you scientifically explain to me the existence of a flat plane?
So I would say that this is 100% a creation of something else that exists outside of it. I don't know what's outside of this reality. And in my opinion, they tell us that outside of this reality is like a vacuum of emptiness and it's just other planets, right? In my opinion, whatever created the Earth exists outside of the Earth. So I think there's a bigger reality that has life and all that outside. Again, I can't prove that, but that's just me philosophically thinking about.
Yeah, so it's more of like a philosophical.
Yes.
Philosophical argument.
Yes,
rather
what
than
you asked me.
scientific.
Yes, what you asked me is a philosophical argument, and I think that it's a creation, and that's why.
Okay, so then I guess where we differ is that I prefer the scientific explanation towards things.
You're talking about the Big Bang?
Yes.
I would say that's not scientific. I would say that's a religion.
Big Bang?
The Big Bang is a religion. So here's the thing. All religions, what do they all have in common? They all have a creation story, and they all have an idea of how to live, right?
Sure.
I would say the globe Earth gives you a creation story with the Big Bang and evolution, but the fact is nobody knows how this place was created. That's where anybody trying to tell you how this place was created, automatically that's a religion. Because the fact is nobody knows. I can acknowledge that it was created.
Yes, and then
but
the
to start
point
claiming
of science is to try and get as close to an accurate truth as possible, right?
Yes.
That's the point of science, and that's the point of things like a gravitational constant that Einstein.
Sure, but his idea of a gravitational constant is not rooted in physics. It's rooted in his imagination, based on what we observe.
A whole bunch of math, because most observations is how science is formed. Is observations that you can prove over and over and over again. So 9.8 meters per second squared being the acceleration due to gravity on Earth in an Earth system, because it's important that's an Earth system, because once you're out of the Earth, that equation no longer functions.
Sure. Okay. Let me ask you this. I guess a more direct question. Okay. Because obviously you believe in the pulling force of gravity, right? And I'm saying it's the other way around. Okay. Let's say we release this object, right? Mm-hmm. And we measure the distance it took for the Earth and this to meet, right?
Yeah.
How can you prove to me that it was the object that accelerated down to the Earth and it's not the Earth that moved up to the object?
Well,
How
I've
can
already
you prove
proven to you the fact that this object does have a gravitational effect.
Okay, how did you come to that conclusion?
Is the fact that that's how gravity works.
Well, how did you come to that conclusion?
So what would cause me to pull this Earth up towards me?
The Earth is moving up. Whatever created this place, put it into motion. So there is a mechanism that's moving the Earth up. I don't know what that mechanism is, but it's a continuous upwards push of the Earth. So the Earth is literally moving up. Just
there's
like
a lot of I don't know.
Yeah, what's outside of the Earth and how it works, I have no clue. All I know is that it is moving up. Because how do I know that? Buoyancy. You can't have a helium balloon get pushed up by the air if the air is not also being pushed up by the Earth.
What contains the Earth?
What contains the air? Well, again, I'm not religious myself, but I acknowledge that there has to be some kind of containment. But the Bible, again, I hate religions, but the Bible talks about a firmament. So the Earth is being enclosed by some kind of barrier. They call it a firmament. Again, I don't go with religions. I stay away from religions, but I do acknowledge that there is some kind of physical containment here. I don't know what it looks like or what it's made out of.
Yeah.
The Bible talks about what it's even made out of, too.
And the containment could possibly be gravity?
No.
Okay,
they say that the air is being contained by gravity, but again, that's you believing in the pulling force of gravity. So let me ask you this: if we could prove that,
my main question is, why is it that you are completely you believe that? You believe that there's a normal force. You believe that, I'm assuming you believe in forces and coefficients of friction, which stops an object.
Yes.
And I'm assuming you believe in accelerating that way, and acceleration can go in any which direction, and balloons go up when they're filled with helium, right?
Yes.
You believe in all that?
Yes. I accept it,
What stops you from gravity?
Okay, so gravity.
Just the water thing?
No, so here's the thing. I'm going to explain it to you in a very simple way. Mm-hmm. Here, I'll use this water bottle, for example. So this will be considered an accelerometer, an analog accelerometer. Why? Because when the water's at rest like this, and it's not moving, right, what we say it's at rest, if I accelerate this container in any direction, the water's going to react. It's going to swish relative to the direction of the force. So if I accelerate in this direction, the water gets pushed to the back.
Yes, but the second that has a constant velocity, the water moves.
Yes. But here's what I'm getting to. So acceleration will always cause displacement. Would you agree?
Sure, yeah.
Yeah. The water will always displace. Even if I accelerate down, the water goes up because it reacts. The water reacts to a force, right? In free fall, however, here, let me show you because I recorded this as well. In free fall, we can see acceleration versus free fall. The one on the right, I accelerated. We see the displacement of water moving. Free fall, there was no reaction of water. The water didn't move up like it should if it was accelerating down because it's just being left behind.
So there is a reason for that, actually.
The explanation, again, it's not a. The explanation that the Einstein gives is the bending and warping of space-time. So he claims that everything's accelerating together.
No, so I'm going to say, because again, I've been doing a whole lot of kinematic equations, specifically on free fall, right?
Yes.
The second you drop it, it has a constant acceleration of gravity. When I am moving it, the acceleration is also changing.
So you're saying that this is free fall right here, by the way,
Yes.
but we see no change within the matter, which we should if we accelerate. But you're saying that it's still accelerating?
Yeah, it's changing direction. It has a constant velocity, but it's changing direction.
But if it was accelerating, wouldn't the water displace? Because we just agreed that acceleration will always cause displacement.
Yes, but we also agreed that constant velocity means that everything... So if I'm in a car, right, the second I reach a constant velocity, I'm no longer being thrown back against my car.
So you're saying...
But the car is still accelerating.
Okay, so you're saying in free fall there is no acceleration then?
There's acceleration.
But you're just saying it was constant. So is it constant in free fall or is it accelerating? When you release something into free fall, does that in your model, does this object accelerate down per second or is it a constant velocity per second?
It's accelerating down towards...
Yes. Acceleration causes displacement. Yes or no?
Acceleration does cause displacement.
But in free fall...
Because it causes a change in direction.
Yes, but in free fall it doesn't. That's why Einstein came up with his theory of relativity, because this debunks acceleration down in free fall. So he came up with his theory of relativity to say that, okay, it's not accelerating down, it's just being moved down because space is bending. So space is flowing down and somehow it's affecting all matter to move down, but not accelerating it down.
Yeah.
So it's like double speaking.
I'm just saying that the flaws in your, I guess, argument are that there's a whole lot of I don't knows, right? So
a whole lot of I don't knows that are irrelevant to the shape of the Earth.
Sure.
But things that are relevant to the Earth, I do have a lot of knows about the shape of the Earth.
Yes, but using gravity, we're able to figure out a lot of your I don't knows. So I guess for me, it's just interesting that you believe in some forms of science, but disregard things like gravity.
Okay, what forms of science I disagree with? Because I'm kind of lost there.
I said you agree with some, like the normal force.
Yes, but what do I disagree? You're talking about gravity in general? Okay, but that's the thing. Gravity as a pulling force, I would say is just a theory that's not even backed by science.
Because the second someone can scientifically prove to me through equations, I can test it over and over and over again, that the Earth is a plane, right? And is able to explain things like GPS.
Well, I can
Do you use GPS?
Yes.
You know that with GPS, they had to take into account gravitational constants to... Yes, they did. Because if they didn't take into the gravitational constant, your GPS would be inaccurate.
You know how GPS works?
Yes.
How does it work?
Global Positioning Service.
How does it work?
It has to use the gravitational constant because when they were first making it, and they didn't take into account the gravitational constant, the GPS was off.
Did you know GPS works through triangulation of ground towers?
Yes.
Yeah, so we don't need satellites for GPS. It's all done through undersea cables and ground towers. So triangulation between ground towers is how you're able to calculate coordinates.
Yes, and it's also done through satellites.
No, satellites is just a hoax to make you believe that we're getting signals from up there, but it's all coming from the Earth. All antennas here on Earth and cables running under the ocean. That's the internet.
Do you know how deep the ocean is?
Nobody knows.
It's very deep.
Yeah, it's very deep. Nobody knows how deep it is, though.
So how will we get the cables down there beneath the ocean?
Yeah, they're floating. They're
on the ocean?
Yeah. Well, they're like underneath, but they're not going all the way to the surface. Like.
And how did we set those up?
You should look it up. They're fucking thick as fuck. Those cables are fucking thick.
They set up the first telegraph cables back in the 1800s.
Yes.
All the way across the world?
Yes. Well, that's the internet.
The beginning was the Atlantic Ocean.
Yes.
That's the first cable.
Across the ocean. Yeah. They're still doing it today. They're replacing cables all the time.
Yeah, but satellites,
Satellites, here's the thing. The only signals that we're getting from above are from high altitude drone planes and satelloons, which are giant helium balloons that NASA and Google put up there. But I think they put them up there for the military.
It would take a lot of effort to get drones that consistently go in a circle.
Yeah, they have drones that run on solar that can stay up for 3 months, literally, because they're very light. So with the solar power that they're able to get, they're able to stay.
Do you know how long Starlink's been up in the sky for? Consistently going around
They
the Earth?
say, 17 years, 18 years, 20 years, something like that?
Starlink, I think it's been around for a little less than...
Oh, less than that?
Yeah, but a couple years.
Oh, okay. I'm thinking of the ISS.
Yeah.
You know, that.
Like after COVID.
Oh, okay. Yeah.
So Starlink's been going around in circles for a while now, right?
Allegedly, sure.
If those were drones, then how would you? When did they replace them? When you're
sleeping, I guess. I don't know. I mean,
okay. What about time zones?
What about time zones? What about them? So the time zones are basically we get them by the motion of the sun. So the sun's right above you. It's noon for you, and then obviously the sun's gonna take time to get to somebody over there. So when the sun gets to them, it's noon for them. So time zones are just based on the motion of the sun.
Okay. So how do you think the sun and the moon?
Well, I would say the sun and the moon, like I showed you the map, Okay, and they're just very tiny in comparison to the Earth, and they just move over the Earth. I don't know.
They're very tiny?
Yeah, in comparison to the Earth. They tell us that the sun is 93 million miles, 500,000 miles in circumference, which is way bigger than the Earth. But in reality, I think the sun is much smaller than the Earth. So it moves over the Earth, and it can only illuminate so much of the Earth at the same time. And because of perspective and mountains and atmospheric pollution, I guess you could say, that's why we can get daylight all over the Earth. Because the sun is not strong enough to illuminate the whole Earth. It's not big enough or strong enough. That's why.
Or it's a globe, which also...
Well, nobody knows what the sun is in reality. Not even globe earthers or physicists. They just make up assumptions about what the sun is, the distance, the size, and all that.
You're also just making up a whole
I would say I don't know what the sun is. I would agree 100%. But that has nothing to do with the shape of the Earth.
Yeah, but you've made an assumption about the shape of the Earth.
No, the assumption of the shape of the Earth is not an assumption. It's based on math and physics. Again, the physical curve of the Earth doesn't exist. You can physically measure that.
We can also physically measure the Earth being a globe.
Well, that's what I'm saying.
But
a physical measurement doesn't exist.
You're using math and physics, and this is where you're using math and physics.
Yes.
But then when physicists and mathematicians actually say, no, man, this is actually how it works, you're disagreeing with
they're just giving me an explanation. That's no different than a priest telling me stories about God, and he can't prove them himself, and I'm just supposed to believe him. They're telling me the same thing. They're just giving me explanations with no practical references. So I'm just supposed to believe. What practical references does the globe have?
Orbits are a practical reference. The fact that the sun does go around the Earth is a practical reference. The fact that you can go from point A to point B is a practical reference.
What do you mean you can't go from point A to point B?
Like on a plane.
You could go from point A to point B. I showed you. Circumnavigation can work on a plane.
But you also told me you didn't agree with that map either.
Yeah, I don't agree with that map, but that's how it would work. Circumnavigation relies on the North Pole to go east and west. It relies on the north.
Yes, but we also talked about how that map was inaccurate.
Yeah, the layout and the size of the continents, I don't agree with.
So if the Earth is flat or a plane, as you say, then how would you accurately depict that map? You can't.
Yeah, I don't need a map, though, to determine that water will always be level when contained and at rest.
So you don't need a map?
That's physics. I don't need a map to prove physics. How water behaves, for example, we can test water here, manipulate it, use it. Understanding that is enough for me to debunk the globe Earth, because they're telling me that water has the ability to form a shape on the surface when it's contained and at rest, which is physically impossible. A physical measurement of the Earth, a lake in specific, will show that that's a physical impossibility.
Water also has a curve to it when it's in a cup.
Yeah, you're talking about.
Curve.
Sure, I agree that there is a slight meniscus or surface tension.
So then it's not completely flat, as you've been saying.
It's level regardless.
Okay.
It's level.
Sure.
Level is no deviation in elevation. In other words, it remains even. It's even regardless. That's my point. The globe Earth claimed that it's not even, that it's curvy. The surface of water curves. That is a physical impossibility. Not only, again, the upwards push of the Earth also debunks the globe Earth without a shadow of a doubt, because you can't have an expanding globe into infinity. So again, the fact that gravity
keeping.
But that's just you. Yeah, that's just you believing that gravity is a pull. But the fact is, gravity is a push, and buoyancy shows us that. Buoyancy is a push of the Earth. You can look up buoyancy as a push. It's an upwards push.
Buoyancy is in regards to water and air.
Yeah. Sure.
Yes.
One last.
Have you ever?
Yeah.
Have you ever scuba dived before?
No, but I've gone in a pool.
I
sure.
have.
Okay.
When I scuba dive, right?
Yes.
I have to control my buoyancy to adjust my level in the water. If I'm too heavy, I go to the bottom. The reason I go to the bottom of the water is because gravity, my mass and my acceleration due to gravity exceeds the water pushing me upwards,
yes.
Right?
Okay.
So you have to adjust your weight, that way you are neutral in the water.
Yeah.
When I drop a rock in the water, it goes to the bottom.
Yes.
Right?
Yeah. That's because the water's not dense enough to push up a rock like it does like a ball.
Then
so
what's pulling
the rock's just being left behind, because the water, the whole Earth and water are moving up through space. So the water's just being left behind. Does that make sense? I mean, the rock is just being left behind, and the water's passing through it. Maybe because water's not dense enough to push up a rock. So here, let me just show you this before you go. It's a 1-minute video.
Sure.
It's an experiment I did, and I want to see if you guys could follow it, I guess. So here it is. Let me rewind it.
Stretch when there's a force.
Okay.
A slinky will only stretch when there is a force being applied. You can test this for yourself. You cannot stretch the slinky without a force.
Do you agree with that?
Sure. So now when you hold your slinky like this, where does it go?
Watch the video.
This is something important to note, as it will make the following experiment much easier to understand. When we have a bottle with water and it's connected to the earth, we can experience weight and buoyancy, which are effects of a force or motion. For example, something that's more dense or heavier than the water by volume, like the slinky, will sink or appear to go down, and something that's less dense, like the ping pong ball, will get pushed to the top or float. If I glue the ping pong ball to the top of the slinky so it can be one unit, we can experience a density gradient. The more dense material at the bottom and the less dense at the top. Also, the fact that the slinky is being stretched shows that there is a force present when connected to the earth.
Would you agree with that? That right now the slinky is being stretched because it's glued to the ping pong ball. So there's an upwards buoyant force right now.
Yes, there's two forces now acting on.
So the slinky is being stretched right now, but obviously it's not stretching itself, the slinky. So there's a force acting on the slinky through the water, obviously, that's stretching the slinky, right? Because the slinky cannot stretch itself.
It's glued to the ball.
Yeah, and the ball
acting a force upwards.
Yes,
so
but
it's got an upwards force and a downwards force.
Okay, sure. But look.
As soon as I release the bottle into freefall, the buoyant force of the ping pong ball and the weight of the slinky completely vanish along with the density gradient. The slinky is no longer at the bottom, and the ping pong ball is no longer at the top.
Yes, and you could argue that's because the normal force acting
shows
up
that there's
on...
no force present. Acceleration requires a force. No force in freefall equals no acceleration in freefall.
So this shows that there is no force in freefall because
Go back a little bit.
A slinky doesn't stretch.
Go back a little bit.
Oh, sure. Where? Yeah, as soon as I release it, it's no longer feeling the upwards push of the earth because it's no longer connected to the earth. So that buoyant effect vanishes. It's no longer stretching the slinky. And it's the earth that just comes up to that whole container again. So that's what happens. And that's what happens in reality. So, one last one. This one I did it with an accelerometer on your phone. Remember I was talking to you about it?
A digital accelerometer is a device that detects the presence of a force or acceleration. For example, when at rest and connected to the earth, it detects 1 g-force. As soon as I accelerate it from being at rest, the accelerometer detects that acceleration by increasing the g-force. Whether I accelerate it to the right, to the left, up, or down, the accelerometer will always detect the acceleration 100% of the time. However, the instant I put the accelerometer into freefall, it detects a deceleration. It goes from 1 g down to 0. If the accelerometer was accelerating down in freefall, it would detect that acceleration by increasing from 1 g, not decreasing. Not only does the accelerometer show that there's no detectable acceleration in freefall, it also shows that the vector or force of the Earth is up. When I switch to the vector tab of the accelerometer, we can see when at rest on Earth, it detects that the vector or force is down, as shown by
that
the green
line right there. You can see.
However, the vector on the phone is inverted because when I apply a force to the right, the vector goes to the left. And when I apply a force to the left, the vector goes to the right. When I apply a force down, the vector inverts up. And when I apply a force up, the downwards vector increases, showing that the vector on the phone is inverted from the true direction of the force or vector. So when the phone is at rest on the Earth and knowing that the vector is inverted, the direction of the force or vector is up. Also, when the accelerometer is in free fall, the vector completely vanishes, showing that it's not being accelerated down by any force, which proves that the force or vector of the Earth is up, not down.
So yeah, so even accelerometers on your phone will show that the force is up, not down. So again, they just inverted the accelerometer on the digital screen to show that it's down when you're holding it. But again, when you accelerate down, that inverts up. And when you accelerate up, that increases the downwards vector on the phone because they inverted it. Whoever manufactures the phones, they inverted that part. You know, but an analog accelerometer like this will always show the true direction of the force. Buoyancy showing, always following the direction of the force. So a helium balloon rises because it's being pushed up by the air, and the air is being pushed up by the earth. So that's the force. It's a push of the earth. You know, and that's physics. Again, I don't believe anyone. I just go with what reality shows me and how matter behaves. You know, and again, this is the biggest lie on earth by far. It has the most censoring by far. I've looked into 9/11. I looked into other conspiracies, and they're all bullshit. Those conspiracies are just there to muddy the waters so that people don't get to this one. Because this is not a conspiracy theory. This is a conspiracy fact. Physics shows that we are being lied to at a mass scale. The reason why, I don't know the full reason because I'm not the one lying, but it's about control in my opinion. So they're dumbing people down so that we're more easily controllable. So that's what it's about. That's what they lie to us. They just want to have a lot of obedient people that just do what they're told. So that's the whole point of government. I don't know if you knew the word government, the word govern means to control, and the word ment means mind. So government, the whole idea is to control the mind. So I don't know if you ever heard of that, but yeah, the whole idea of government is to control the population. And they do it by disconnecting us from the true nature of our existence so that then we're just believe philosophical ideas of what we should be doing, you know, based on a false premise, you know. So yeah, any questions before you guys go, I mean, about this subject?
I mean, it's clear that, you know, you're very set in your...
Well, again, it's not that I'm just set in my... If you could show me something practical that can physically prove a globe Earth, I would gladly go back to the globe. You know, I didn't want to leave the globe. I was actually a globe Earth fanatic. I was borderline a NASA fanboy. You know, I used to look at alien videos all the time, fascinated by outer space and other planets. Trust me, so I was all about that. I didn't want the Earth to be a level plane. You know, I wanted the Earth to be a globe, you know. But
well, I mean, the physics department is down that way if you want to go talk to physicists to
I've talked to a few physicists, but to be fair, I've talked to one physicist, and right when I started presenting the physics that contradicts his beliefs, he just walked away. So they're not willing to have a conversation, an open conversation.
Or it's more, you know, like, you know, you can't win an argument against someone who's very set in...
But that's the thing, though. They say that, but they'll never have the actual intellectual conversation with someone like me. They'll have a fake flat earther, again, these motionless flat earthers on talk shows, and they'll just make a mockery out of them, and now they think they prove the globe. So that's the way they're doing this. They're just putting in a lot of fake interviews in the mainstream with a lot of dumb flat earthers, and they're just giving over... they don't even talk about physics, by the way. They talk about bullshit, and that's how they're making this whole subject look stupid. It's by highlighting these dumb flat earthers, these motionless flat earthers. So that's the control doctrine, you know. The reality is, out of the hundreds, even thousands of channels, including Globe Earth channels and Flat Earth channels, there's only 2 channels that are sticking to physics, which is myself and one other channel that's in here. You can look it up. It's Beyond the Imaginary Curve. He's from the UK in Scotland.
All right.
It's right there. So these are the only 2 channels, myself and him, that are literally talking about physics when it comes to the shape of the Earth.
Well, my challenge for you then is if I give this a look, I want you to go take a look at kinematic equations and try and solve them without using an acceleration due to gravity.
Yeah, easy. Yeah, because you're just calculating distance over time. It's like how skydivers measure their speed. They're using GPS, which is distance over time, but they're not calculating their actual acceleration down. They're calculating the distance of the Earth moving up.
Things like freefall and with kinematic equations, you'll find that it is actually far more complicated for the most part than acceleration due to time. And sometimes without a certain variable, acceleration due to gravity, you can't really solve.
I would say that they do account maybe air resistance, and they do take account of all these little factors, right, to get an accurate number, right? But at the end of the day, you're not measuring the downwards acceleration of a free-falling object. You're simply just measuring the distance that it takes for for the Earth and the object to meet. We're not measuring what's moving towards what. Does that make sense? We're not measuring whether this moves down to the Earth and how long it took, or if we're measuring how long it took the Earth to come up to the object. We're simply just measuring that distance. We're not measuring what moved towards what. Does that make sense?
Sure.
Yeah. So I would say that doesn't prove anything. Measuring distance over time in free fall.
And then if the Earth is always going up, then how come, you know, the moon isn't getting closer?
Oh, because it's all part of the system. It's like in a car. If you're moving in a car, everything inside of the car is moving along with it. You know, so it's kind of like that. We're inside of this, I would call it, you know, like a giant spaceship, right? And it's all moving together.
Sure.
You know, and the Earth, and then the sun, moon, and stars are part of this spaceship. You know, you could call it Earth. You know, so it's all moving together. It's all one unit. So the sun, the moon, it's all part of the Earth system. You know, it's all working together. It's all like, I would say, it's all like a machine that's working together. The sun, the moon, the stars, the Earth, everything is working together. It's all one unit. You know, so what's outside of this reality? I have no clue. I don't think we could go outside of it, in my opinion. I think whatever's containing this Earth is impenetrable. We can't leave it. And I think the governments have figured that out. And that's why they came up with this whole globe Earth bullshit, you know. But, Well, yeah, I appreciate the chat, and yeah. Do you have a flyer? Do you want to take one? You can take it.
Oh, good. Thank you, though.
Yeah, all right.
What's
Appreciate
your
it.
channel name?
You could scan it. It's Levelheaded William.
Got it.
Levelheaded William. Yeah. Yeah, and I had a conversation actually at this university with a physics professor, and to be honest, he was probably worse than you. Like, you know, he just didn't have much to say. He just believed what he was told. Eventually, he just walked away. Yeah. So.
Yeah. Well, I mean, if you ever want to talk to more, the physics department is quite literally down that way.
I have a feeling that they're just gonna like laugh it off and walk away.
I mean, most of them do study
Yeah.
this stuff as like their life's work. So
I would say they just study this off books when I'm studying reality. That's
I mean, they do experiments all the time.
Sure.
They're also very much reality.
Sure. But I would say those experiments, there are faulty conclusions because they're starting off of a false premise.
Yeah. Well, like I
Oh, yeah.
said, I mean, try out some kinematics with Freefall, right?
Sure.
See what conclusions you come to from there.
Sure. So I implore you to look at, I have a playlist of different experiments. I have like 10 different experiments.
Yeah, I'll look at them.
And yeah, they all prove that there is no physical downwards force of free fall. Using different states of matter. I use flames as well. Flames, I use a bunch of different objects. You
Yeah.
can see.
Okay,
Yeah.
well, it was
So,
nice
appreciate
talking to
it.
you, man.
Thank you. Yeah, bye man. Appreciate it, man.